This problem is related to Bohr quantization, and in this case you have to use concept of circular motion also. So the problem says a particle of mass m is moving in a circular orbit under the influence of the central force F, which is a function of r, and this is equals to minus k times r. So we have a particle and this particle is moving in this circle, and a force is acting on this particle, and this force is acting towards the center, and the magnitude of this force is k times r. Negative sign shows this force is acting towards the center. Now the problem further says, for this particle corresponding potential energy is V as a function of r, which is equals to k r square by 2, and k is a positive constant and r is the radial distance from the origin. So now I know the potential energy for this particle, which is a function of r. Now according to the Bohr quantization rule, the angular momentum of particle is given by L, which is equals to n times h has, where h has is equals to h by 2 pi. Now h is the Planck constant and n is a positive integer. So these things are given. Now question says, let us say v is the velocity, that is a speed in this case, and E is the total energy of this particle. Then we have to find which of the following expression is correct. In other words, we have to find what is the value of r square, what is the value of v square, what is the value of energy, and similarly what is the value of angular momentum. So we will try to find this value using concept of circular motion, Bohr quantization, and concept of total energy. So let us do this problem. Now first I will write equation of motion for circle. So if you remember the Newton's second law, in case of circle we write F is equals to ma. In this case force in the radial direction is equals to mass into acceleration in the radial direction. And the force is what? The question gives the force is minus kr, and negative sign simply says this force is acting towards the decreasing r, that is towards the origin. Increasing r is in this direction and decreasing r is towards the center. So magnitude of force is kr, and which is equals to m times radial acceleration, and if you remember radial acceleration is nothing but v square by r in case of a circular motion, uniform circular motion. Now I can calculate from here v square, and v square will be this kr divided by m, and this r will multiply, so this will become kr square by m. So now I know v square, then I can calculate v. So if you take a square root, this becomes r times a square root k by m. So this is equation 1. Now let us apply Bohr quantization, and in the problem it is given that angular momentum of this particle is equals to n times h has. Now what is angular momentum? So if a particle is moving in a circle, angular momentum is r cross mv. Basically r cross mv is a general formula to calculate the angular momentum, and in this case r and v makes an angle of 90 degree. So r cross v is simply r v, and then you have mass. So mvr is the angular momentum in this case. So mvr is equals to nh, basically h has. Now we can plug the value of v. So if you remember, we have calculated this v, so let us plug this value v here, and then this r is here, and this is equals to nh. So r into r, that is r square, and now if you rearrange all the terms, then this is r square is equals to nh has divided by a square root k times m. So we have written two equations, one for circular motion and another for Bohr quantization. So we have this one equation and this is the second equation. So if you see V, I have a function of R, and R I can calculate from here. So if I plug the value of R here, I can calculate V. So let us square the first equation. So if you square, so this becomes V square, and this is equals to R square K by M. Now putting R square from equation 2 in this one, so you will have V square, and this is K by M, and R square is this term, NH by under root Km. Now if you simplify, then V square is simply NH bar or NH has, whatever you call, and this is a square root K by MQ. Now I can calculate total energy, because in the problem you also have one option for the total energy. Now what is total energy? Total energy is sum of potential energy plus kinetic energy. But the problem gives you expression for the potential energy, and that is half kr square, and kinetic energy is half mv square, we know. So now we can plug the value of v square here, and then I can get the kinetic energy. So this is half kr square, and this is half m, and v square is simply r square k by m. So this m and this m cancels out. So we will have half kr square here, and here also we will have half kr square. So half kr square plus half kr square is simply kr square. So total energy is kr square, but r square is this term, that is nh by a square root k times m, and this is, you can call it h has or h bar, or simply sometime I am pronouncing say h in this problem. So this is k times nh by a square root km. Now if you further simplify, so this becomes nh, and this one of the k, if you take this k inside the square root, then this becomes k square. So 1 k will cancel out, so we will have k by m. So now I know the energy, that is nh times a square root k by m. So we have angular momentum, we have, so basically you can calculate, because you know the r and v, you can always calculate angular momentum. So m times v, we have calculated this value, and this is r. So mr square times this, but we know value of r square, so we can plug this. So this becomes L by, or simply in this case you can keep this r square, because in the option you have r square. So this will be L by mr square, and this is equals to a square root k by m. So this m is inside the root, so there is a mistake. So this m is inside the root. So basically now I have expression for v, I have expression for angular momentum. Of course this is a square root k by m, and I have expression for r square, and I have expression for energy. Now you can check the options. So these are the 4 options. Now if you check these options, so first A, B and C options are correct, and D option is incorrect. In this case you see energy is nh, a square root k by m, but here you have 2. So this is not here. So that's why this option is incorrect. I hope you enjoyed this problem, and if you like my videos, please share with your friends, and I will see you in the next video. Thank you.